Hello guys, so here we are with another question on number properties. This is problem solving. So here it says that n is a multiple of 6 and they're asking which of these can be the value of root over 72n. So there are some options, okay, obviously like 5 options. You have to choose the answer that is possible. So one way of doing it is you can equate, okay, root 72n equal to 12 root 2 square, both sides factorize and do stuff, okay. So that's going to take a lot of time. The other is you factorize, okay. So use a substitution. When I say that n is a multiple of 6, remember, just put n equal to 6m, where m could be 1, 2, 3, 4, dot, 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 dot. Okay, that's what multiples mean. Whenever you come across a statement like this, you can just use this substitution. Plug in here. So we are going to get root over 72n as this. 72 times 6 is 432. So that's 144 times 3. Okay, or you can just break it down as 8, 9, and 6 m. So that's inside the root. So 1, 2 goes here, it becomes 16 and this becomes 3. So 16 outside, so 4, and there's a 27 here, so 3 and a root over 3m. So the final thing that we get is 12 root 3m. That is the final form of this number. Now see, m could be any of these. So m could be 1, 2, 3, 4, and so on. If m is 1, 2, a non-3, that is, then you will always have a 3 multiplied with something else inside the root. And if m becomes a 3, then the 3 and 3 will combine and go outside, make that 36. Obviously, something else can also transfer out from the root, because say for example, m is 3 times 4, then a 3 will go out. So, and also the root over 4 is 2, so 2 will also go out. Okay, so multiple things can go out. So essentially what we are trying to say is either the 3 will remain inside the root and it will remain 12 root 3 types, versus, or alternatively, or a 3 will go outside and it will become 36 root something. Either of these forms will be there. Now we need to check one by one what the answers are. Clearly statement number 1 is not valid, because though it has the 12, there is no 3, and m cannot be a fraction like 2/3 or something, which will eliminate the 3 inside the root. So that's clearly ruled out. B is also ruled out, because where did the 3 go? So m could be 5, so there is no issue with the 5. Okay, it could be 7, 11, whatever inside. Okay, there is no problem with that. The problem is with where is the 3? So if the 3 had to go outside, then you would have a 3 times inside outside, right? 12 times 3, 36, not a 12 times 2, 24. Not possible. In option C, the 3 is not inside, but the 3 is actually outside. But unfortunately, there is a 2 less, because if the 3 were to go outside, as we said, that there must be 36 here. Okay, not 18, because 18 means a 2 missing, and we already had 12 as 2 squared, right? 2 squared times 3 outside times a root 3. Here 2 squared times 3 times a 3. This 2 squared times 3 must be there. 18 is 2 times 3 squared, so there's a 2 missing. And same thing here as well. In 54 also, it is 2 times 3 cubed, so it's still there is a 2 missing. Only in E, where we have 108, that's 36 times 3 times root 2. So that can be thought of as inside that 3m that we had. So we had 12 root 3m, right? So 12 root over 3 times m. So what could have been this m? First of all, m has to have a 3 in it. Why? Because only then the 3 and 3 will combine and go outside and give you a 36. Not only has a 36 come out, but a 3 has also come out. So that means there must have been another 3 squared. This 3 squared square root is 3. That 3 has gone outside. Okay, so these two combined, 1 3 goes outside, makes it 36. This 3 squared square root gives you a 3, and you still have another 2. So this is your value of m. So that's okay, right? There is no restriction on what the value of m could be. And this satisfies all the conditions. So our answer is option E. I hope this was clear. Thanks for watching.